In this video, I want us to understand very well what product rule is. What did it come to solve? Why did the scientists come up with it? Which problem was it coming to solve? Product rule. Now, product rule earlier alone, before the product rule, it would be easy differentiating something like this. You will say, as a product, you hear it multiplying two things. Okay, so it would be easier to say to differentiate. For example, if you have y is equal to x into x minus 1, this one would be easy. You would just expand. So you say, well, your y is equal to x square minus x, and this one would be easy to differentiate. You would say your dy by dx is the same as 2x minus 1. Chalinga changu, it is easy. Even if they say, for example, y is equal to x square into x plus 2, isn't it? This one is easy to expand. Yeah, you can expand. Even if you can expand and say this is x power 3 minus plus 2x square, and then you differentiate, you get your dy by dx. It is easy. So which is 3x square and then plus 4x. Even if it would be like y byalinga byangu neoberanga ina x minus 1 into x plus 2, this one you would expand and differentiate. However, singene ekyukamu, and then it is like for example, y is equal to x into x minus 1 power 7. This one you can't now. It's not easy. It's not easy to just simply expand and then you multiply and then differentiate. That's tedious work. That's too much work. Even if neno ne bagikyusamu, for example, if you come and say now we choose maybe, for example, x square into x plus 2 to power 4, is still one error. This normal expansion wouldn't work. Kiba tekikola. Newe tugamba nti kati tugenze kwenesemba, we have now changed it. X minus 1 power 4 into x plus 2 to power, for example, 3. Now this one, you can't use the normal expansion and find the derivative. That's too much work. You can use it, but that's too much work. However, this is where product rule came into play to solve such issues. Now we are going to see a product rule, how it came into play. Now product rule says, this is how product rule came into play. Product rule says that if you have a function y is equal to uv, where u is a function of x and also v is a function of x, where u is a function of x and also v is a function of x or any other variable, but we normally use x because it's the independent term on the axis. Now etugamba, it comes and says that if we have a small change, in y plus the y, we actually get the corresponding small changes in these two functions. For example, we obtain that change in u. That change you are writing here it as delta y and then delta u. Delta u is that small change in u. So we have also v plus delta v. Delta v is that small change in v. So we are simply saying that a small change caused in y comes as a result from the changes obtained in u and then the changes obtained in v. Now, our delta y plus y is the same as, we can expand this. So when you expand this, we shall have this times that, we shall have uv, and then this times this, we shall have u delta v. I want you to stick with me such that you clearly understand product rule, and at the end of this video I'll give you your trial question such that you fully understand what product rule is. It's so easy, things. So easy. So this times that, we have obtained that, and then multiply this times this, we shall have plus v delta u, and then this times this, we shall have plus delta u times delta v. Now we are interested in delta y. So we shall have delta y is equal to this y will go this other side. So we shall have a uv plus u delta v plus v delta u, and then plus delta u delta v y minus y, but y is what? Y is uv. So do we realize that this cancels with this? So we have delta y is actually equal to u delta v, and then plus v delta u, and then plus delta u delta v. Now we can go ahead and divide throughout by delta x. So dividing throughout by delta x, change in x, that small change in x. So delta x, everything, delta x. So we have delta x, delta y out of delta x. Delta is mean is small change, is equal to u delta v out of delta x, and then plus v delta u out of delta x, and then plus delta v times delta u out of delta x. Now wano wetugambira nti as delta x tends to 0 ng'efuuka ntono nnyo, delta v times delta u, something so small multiplying with something so small, it approximates to 0. So it goes to 0. So after going to 0, that's where we come and say, if I draw a line here, that's where we come and say that we shall have our, now as this one goes to 0, delta y out of delta x becomes dy by dx, and your delta v out of delta x also becomes dv dx, and also delta u out of delta x becomes du dx. So bwetuzizaamu wano tujja kubeera ne dy by dx is equal to, this one is going to be u, ogirabye, this delta v over delta x becomes dv dx, and then plus v du dx. Kati kino kye tulina wano, this kino is what is known as product rule, kye tuyita product rule. And we are going to see examples concerning product rule such that you also understand how to use product rule. Katufune example esooka. I'm going to give you a trial question, so I want you to understand this one very well. So example, let us see example 1. Now example 1, if they tell you find dy by dx, and then they give you the y. For example, y is equal to x minus 2 squared, and then into x squared minus 2. Now, first of all, in such a case, this is where powers are whole numbers. Powers are whole numbers. They have no problem. Now, what do? You first know who's your v and then who's your u. And now this one is our u, and then now this is our v. Why? Because you said product rule tells us that y has to be u v. So the first one is u, and then the next one is v. So the next thing we state the product rule. Product rule tells us that you have, if you are to get it dy by dx, it is u dv dx plus v du dx. Meaning you need dv dx, you need du dx. Now here your u is x minus 2 squared. Eyo ye UU. Now, do you remember the chain rule simplified? Those who have not yet seen that video, I'm going to link it in the description. Now, we have what we call the simplified chain rule. One way kuyambira. This is where it helps you. So, we get du dx as drop the power 2. Leave whatever is in the bracket alone. Reduce the power by 1, it becomes 1 times the derivative of what is inside, which is 1. So this ends up being 2 into x minus 2. That's our derivative there. So we get also our v is x squared minus 2. So we get dv dx. When you differentiate dv dx, you have it as 2x. Drop the power, reduce the power by 1 is 2x. Now, we are going to substitute back. Our dy by dx becomes, our u is x minus 2 square. That we take out x minus 2 square. Now, dv dx is 2x plus v is x square minus 2 times du dx. Du dx, are you seeing it? It is 2x minus 2. Now, substitution is correct. So the next thing is to simplify. So this is how you defeat a number. If you haven't subscribed, please consider subscribing and share this video with your friends such that you understand together. Now, here the next thing, this you have already substituted in very well. So the next thing is simply simplifying. So how do you simplify? If you look at what we have here, we have a common factor. That common factor is 2. And then after that common factor, we have also another one called x minus 2. So I pull out 2 first. There is x minus 2 here and x minus 2 here. I pull out 1. And then what do I remain with inside? Here I will remain with the x. Here I will also remain with 1x minus 2 plus, then here the 2 is out, the x minus 2 is out, so I remain with x squared minus 2. So going to simplify this, I'll have 2x minus 2 into, when I expand this, I'll have x squared minus 2x plus x squared minus 2. So when I go ahead to simplify this, I'll have 2 into x minus 2 into, this one is going to be x squared plus x squared. We have 2x squared minus 2x minus 2. So I can pull out the common factor, which is 2, and I end up having 4 into x minus 2 into x squared minus x minus 1. Here you have defeated the number. So this one is the derivative of y is equal to x minus 2 squared into x squared minus 2. So this is our first example. Let us look at the next example and I give you your trial question. Our next example says, example, differentiate x squared into x plus 1 everything square. Now here they have not given you the y. So whenever you find such a thing, you have to first let y, so let y equal to what they have given you. Why do you let y to be that? Because you are going to use what to call dy by dx. So now when you find such a thing, the next thing we begin. Who's our u, who's our v? So it's always better to first state chain rule. So our dy by dx is the same as u dv dx plus v du dx. So we come and say who is our u, who is our v. So our u is x squared, and then our v is x plus 1 everything squared. So when we differentiate du dx gives us, when you differentiate this, we shall have 2x. dv dx, when you differentiate v, you'll have 2 simplified chain rule. Check in the link in the description such that you can also see that chain rule. So this is drop the power, which is 2, leave whatever is in the bracket alone, reduce the power by 1, we get 1. So this and differentiate what is times the derivative of what is inside, which is also 1. When you differentiate x plus 1, you get 1. So we have 2 into x plus 1, that is our dv dx. Now we substitute in our dy by dx. So dy by dx gives us u is x squared. dv dx is this times 2 into x plus 1 plus our v. v is x plus 1 squared. du is 2x. So we have 2x squared x plus 1 plus 2x x plus 1 everything squared. Now we simplify. Now when we simplify, if you really see that we have a common factor, the first common factor is 2, so we pull it out. The next common factor is x. The other one is x plus 1, is also common, x plus 1. So what are we remaining with in the bracket? We are remaining with here, we are remaining with only x. And then here we are remaining with the x because this one has moved out, 2 has moved out, and one of the x has moved out. So we remain with x plus, now what are you remaining with here? 2x is already out, one of the x's go, so we remain with x plus 1. So when we simplify this, we shall have 2x into x plus 1 into, this is going to be your 2x plus 1, and this is our dy by dx. Now your trial question. Trial. Yeah. Find dy by dx. Your trial question. What are you finding? Y is equal to 1 plus x square, then square into 1 minus x square. I want you to try out this and drop your final answer in the comment section. Don't forget to subscribe if you haven't subscribed. Like the video and share it with your friends such that you understand together. We meet in the next. Thank you.